Here's another example of linear programming, one in which we're going to first try to actually minimize a certain quantity. So we have that a coffee shop wants to minimize their cost for making drinks each day. Due to the constraints of time as well as supplies, the coffee shop can produce no more than 400 lattes and no more than 300 mochas each day. The coffee shop wants to make at least 500 of these coffee drinks each day to be able to sell. Now, the cost for the business is $2 per latte, and the cost of a mocha is $3. So what is the minimum possible cost each day? So there is some more text that we will come and consider kind of a little bit later on. So right now, we're just going to consider kind of that first paragraph and just ignore that those second couple sentences there. So with this linear programming problem here, it turns out that I don't think we know the number of lattes, nor do we know the number of mochas that we want to make. So let's define, how about x to be the number of lattes that we want to make, and then we'll let y be the number of mochas that we want to be able to make there. So our objective function should be kind of our goal that we want to be able to accomplish. And the goal here is that the coffee shop wants to have the minimum amount of cost. And so let's define, let's say, C to represent cost. And the cost here is going to be $2 per latte, and then add together with that $3 per mocha. And that's going to be their cost. But we're going to try to find what's going to be the smallest value of C to try to minimize their cost, right? All right, so with that, there's some constraints that we also want to be able to consider here. So it does say that they can make no more than 400 lattes and no more than 300 mochas each given particular day. So that does tell you that the number of lattes needs to stay under 400, and then also the number of mochas needs to stay equal to or underneath 300. But then also we want to be able to make still at least 500, right? They do want to have, make some profit and sell at least a minimum amount. So they want to sell 500 coffee drinks each particular day. So the number of lattes plus the number of mochas needs to be equal to or greater than 500. And so that would give you the different constraints that then now let's go ahead and graph and see kind of what we get there. So let's go by hundreds like this every 4 squares or so. And then we'll do the same thing along the y-axis here. So recall that the y-axis here is dealing with mochas, or the number of mochas. And then right here, this is dealing with the number of lattes. So with the constraint that we have right here, first of all, that's telling us that we can make at most 400 lattes. So that would be right here is where 400 is for lattes. That would be the line that we can't cross to the right of that. We have to stay to the left of that always. And then we also have the fact that we have to make at most 300 mochas. So we're going to have to stay below that purple line for sure. And then another constraint is going to have to be that x plus y is greater than or equal to 500. So with that particular constraint right there, that's equivalent to having a y-intercept at 500 and a -1 slope. So it's going to be this particular line that goes like this. And we're going to stay above that, it looks like. So it turns out that here, I guess, our feasible region ends up being kind of this triangular region that we're seeing right here. And so now we do have a closed region, so that means we're going to find the minimum and maximum of our objective function at each of these corner points. So it turns out that right there, that's going to be 200, 300, and over here is 400, 300, and then down over here is 400, 100. So we're going to have to consider each of those corner points underneath our objective function. So 200, 300 that we'll plug in, 400, 300, and 400, 100. So we'll want to take 2 times x plus 3 times y, so 2 times 200 plus 3 times 300, it's going to equal 1,300 there. And then 2 times 400 plus 3 times 300, it's going to equal 1,700. And then finally 2 times 400 plus 3 times 100, that's going to equal 1100. There we go. So so there's a little bit of a typo that I have right here. It says maximum profit. We're actually trying to figure out what the minimum cost is in this particular first scenario here. And so the minimum cost is going to be $1,100. So they'll be able to minimize their cost within that system of constraints. So have a cost to the business of $1,100 when there are 400 lattes and 100 mochas. And so under that particular constraint, they stay underneath the limits of lattes they can make in a day as well as the limits of mochas they can make in a day. But then also, collectively, that makes 500 drinks, which they at least wanted to make per day as well.